All right, there's one last measure of center that we have to talk about, even though it's the most sort of clunky, elementary measure of center that you've ever seen. It's called the mid-range. Mid-range. And I'm going to go back to our data set over here, just so you can get an appreciation for what's going on. God, I beat these things up in these presentations, don't I? The range of the data, the way to describe the range is simply to take the highest and subtract it from the lowest. And that's actually a measure of spread, which we'll discuss in the next little unit. However, what the mid-range is it's very, very simple. Like I said, you could teach your 6-year-old, I have a 7-year-old son, I could probably teach it to him. You take the lowest value, which I think was 4.5, and you take the highest value, which I believe was 40, and you divide it by 2. In other words, it's the average of the lowest and the highest. It doesn't really give us a whole lot of information. It just tells us where the center point is between the lowest and the highest, which, what would that be, 22.25? 2.25. Oddly enough, because of the way that the data distributes itself, it gets pretty close to both the mean and the median. Okay. Now, I want to give you one more piece of vocab just really quickly, and then I'll be done. You guys are probably tired of listening to me, but that is what it is. Let's look at distributions, for example, and see, we're not in complete absence of data. Let's see if we can try and decide where the mean, the median, and the mode would live given a certain distribution. All right, so let's keep it simple. Let's talk about one like this. So this is going to be basically a histogram, just a really smooth histogram. It's pretty simple to see. It's pretty easy to determine just by looking at the distribution where the mean, the median, and the mode are going to live. Well, the mode's the easiest because it's going to live at the highest value. So we know for sure that the mode's going to be there. The median, remember, the median splits the data in half. Because of the apparent badly drawn symmetry of our data, I'm going to have the mode here. I'm also going to have the median. All right, because it splits it in half, so 50% of the data lives over here and 50% of the data lives over here. And then if you think about how an average works, this little guy plus this little guy way out here, if I take the average of those, it's going to be here. If I take any point around this axis of symmetry and I add those up and divide by 2, I'm going to end up in the middle. And that's really an oversimplification of how to find the mean. Actually, I guess it'd be an overcomplication if we were to add them all up. Okay, so the mean, the median, and the mode, because of the symmetry of this, lives in the same place. All right, how about one of these guys? This, if I were to go... All right. Now what I have is what's referred to as bimodal. Bimodal means I have two maximum values, or excuse me, two maximum numbers or maximum frequencies of data values. It's called bimodal. If I had 3 humps, it'd be trimodal. That's referred to as a multimodal data set. All right. So I'd have a mode here, and I'd have a mode over here. However, my mean and my median would live right in the middle. So here's my mean living here, and so would my median. Again, the arguments are easily made. The mean, it's just balanced right through the middle. Think of the mean as the balancing point of the distribution. It'd be the place that you'd have to stick your finger if you were gonna balance this figure, so to speak. The median splits, again, 0.5, 50% of the data is over here, 50% of the data is over there. Now, let's get into something a little more interesting, just this last little topic before I let you go. What if you had this guy? You got something going like this. Woohoo, like that. All right, now it's easy to see where the mode is. It's the highest value, right, or the highest occurrence, so the mode is here. Now, what do we know that we're assuming that these values out here, somewhere out here we got ourselves some outliers. In other words, they don't really fit in with the other parts of the distribution. And hopefully we know that outlier, what they do is they pull the mean to them. So these values that don't have a very high frequency number are going to take the mean and pull it over to them. So the mean would live over here. But we also know that the median is resistant to outliers. It may get pulled, but it's not going to get pulled as far. So the median is going to live somewhere around here. I'm going to draw this in here. median. And the easy way that I remember this is the median is the physical middle of the data value. It's also when you've got this non-symmetric distribution, it is the physical middle of the measures of center. The mode is on one side, the mean is on the other, and the median splits the difference. This is called skewed data. Skewed. And in this case, because the skew, I believe in French, skew means right, or right, try that again. I believe in French, skew means tail. So what I have is a skewed right data. Skew, when you see skew in a data set, your spidey sense better start tingling because some weird stuff's going to happen. Your measure of center is going to get crazy. Depending, your mean could be way out of whack because it could be getting dragged by these outliers to give you a value that's completely non-representative of what's really going on. An example of when my spidey sense tingles when I hear a statistic, especially in context of what we've been dealing with in our economy, it's the housing market. When you hear somebody give you an average value of an average home value in a community, let's say, well, that average is going to be way off because you're going to have, like, I mean, most communities have multi-million-dollar houses. Now, there may only be, I don't know, 15 or 20 of these, but these outliers right here are going to drag the mean, the average value of a house in that community way up. There aren't any houses that are worth $0. They usually get torn down and they aren't considered homes anymore. So what you'll typically hear as a statistics, as a measure of center of the housing market in a specific community, is a median value. If you don't hear a median value of home values in your community, hopefully at this point you're starting to get a little suspicious of the information. It might be a little bit apocryphal in terms of what they're trying to tell you. So anyway, a right skew looks like that. A left skew, hopefully you can sort of figure this out. A left skew badly drawn is going to look something like this. So you've got this skew over here. Right here would be considered the skew. Sorry about my lousy drawing. All right. Well, that's about it for the first section of Chapter 3. I hope you enjoyed it. Tomorrow in class, I'll be showing you a bunch of techniques with using your calculator to be able to figure out a lot of the heavy lifting with the computations of these formulas. Okay? Have a good day. We'll see you tomorrow.